Hello, my name is Gabe. For this problem, we're asked to find the maximum and the minimum values of our objective function z equals 2.5x plus y, subject to our constraints. X is greater than or equal to 0, y is greater than or equal to 0, 3x plus 5y is less than or equal to 15, and 5x plus 2y is less than or equal to 10. Now I've begun by sketching these four lines and then shading in the region which is bounded by our constraints. So this means that any of our feasible solutions have to lie in this region here. So before I begin, note that I've labeled 3 of the 4 vertices. I just want to spend a quick minute reviewing how to find this vertex here. So this vertex is going to happen when these two lines intersect. So when y equals negative 5/2 x plus 5 and y equals negative 3/5 x plus 3 intersect. So let's start by just considering these two lines. Y equals negative 5/2 x plus 5 and y equals negative 3/5 x plus 3. Now to find where these two lines intersect, we'll wish to set them equal to each other and solve for x. So we'll substitute the expression for y in the bottom equation into the top equation, which leaves us with negative 3/5 x plus 3 is equal to negative 5/2 x plus 5. Here we can begin by adding 5/2 x to both sides of the equation. So we'll have negative 3/5 x plus 5/2 x plus 3 equals 5. And we can subtract 3 from both sides of the equation also. So this will leave us with a negative 3/5 x plus a 5/2 x is equal to 2. Now at this stage, we can go ahead and get common denominators. We'll multiply negative 3/5 by 2 divided by 2, and we'll multiply 5/2 by 5 divided by 5. So here we'll have negative 6/10 x plus 25/10 x equals 2. Adding these, we'll have 19/10 x equals 2. Solving for x by multiplying both sides of the equation by 10/19, we'll have x is equal to 20/19. So this gives us the x-coordinate of this point. So now to find the y-coordinate, let's take this and substitute it back into either of our initial equations. Let's go ahead and let's substitute it into the first one. So we know that x is 20/19. So y is going to be equal to negative 5/2 times 20/19 plus 5. Here we can go ahead and simplify. So we have y is equal to negative 5 times 10/19 plus 5. Here we can go ahead and we can get common denominators by multiplying 5 by 19 divided by 19. So we have y is negative 50/19 plus 95/19. So what we get is we have y is equal to 45/19. So that means this point here has x-coordinate 20/19, and the y-coordinate is 45/19. Next, we want to try to find the maximum and the minimum values of our objective function in this region. So let's go ahead and let's evaluate our objective function at each of the vertices. So let's start at the origin. So at the point 0, 0, z is equal to 2.5 times 0 plus 0, which is equal to 0. Let's look at the point 2, 0. Here we have z is equal to 2.5 times 2 plus 0, which is equal to 5. Next, let's look at the point 20 19ths, 45 19ths. Here we have z is equal to 2.5 times 20 19ths plus 45 19ths. Now I've worked this out beforehand, and I know that this is equal to 5, but you can check this on a calculator. And finally, let's check our last vertex, 0, 3. So at 0, 3, we have that z is equal to 2.5 times 0 plus 3, which is equal to 3. So just by looking at this, we see that our minimum occurs at the point 0, 0 and is 0. And again, that's just because 0 is the smallest of these numbers. Now, looking at our maximum, we see that we have 2 5s, where 5 is our largest number out of the remaining 3. So our maximum is actually going to occur on a line segment connecting the point 2, 0 and the point 20 19ths, 45 19ths. So maximum is 5. And this, like I said, this happens on the line segment. Connecting these 2 points. So connecting the points 2, 0 and 20 19ths, 45 19ths. Thank you.